Hello, everyone. Today we're going to be going over the FIVES acid-base inquiry lab, which is in your new unit pack. At the top, it talks about a dry lab. This is going out on the internet, going to a site called PHET, P-H-E-T. You can do a couple simulations with some acid-base kind of things to try to gain some information by playing around. This is also listed in your planner if you want the exact links. I'm going to go down to the wet lab part, and we're going to start to show you the lab that you would do if you were actually in class. So there's a couple rules up at the top. This substance right here is called phenolphthalein. Phenolphthalein is clear and colorless. If you look in there, it looks like there's some white crystals in there. That's actually some of the phenolphthalein that's come out of the solution. But it is clear and colorless. Phenolphthalein is an acid-base indicator. When it comes in contact with a base, it turns pink. And when it's in contact with an acid, it stays colorless. So it says never put any of the phenolphthalein in the bottles that we are using. Some of your teachers will do that, but you should not do that. B, it says never let the eyedroppers touch the table, another eyedropper or another solution. And C, it says only take out one eyedropper at a time to avoid placing the eyedroppers in wrong bottles. So here we go with the lab. It says look at the back of your front cover to obtain some information on phenolphthalein. So you should pause the video right now, give that whole back side of your front cover a good look over. That has just about everything that you need to know for this unit. But right now you're looking for some information on phenolphthalein. So we're looking, what does phenolphthalein do? And if you listen to what I just said, I already told you what it does. So pause the video, take a look at the back of that front cover. So assuming that you did that, you pause the video and you did that, I'm going to go on to number 2. It says phenolphthalein turns pink in a base, and that is found on your cover, and that's kind of key to this unit. Phenolphthalein turning pink in a base, and a base is hydroxide ions, and acid is hydrogen ions. Number 3, it says use a spot plate. It talks about how we're going to clean these. We hit them with tap water. That gets out most of the stuff that's in the spot plate. Then we spray it with distilled water to get rid of any ions that are found in the tap water. Then we dry it, and then it's ready to go. Number 4 says don't waste solutions by using squirts. You want to be counting drops. This, by the way, is a spot plate. We used them in our last unit. They were black. These are white. So now I'm going to get some things set up for you. So hopefully you don't get motion sickness as I move the camera. So bringing that in so you can see what's going on. So that is our spot plate. And number 5, it says place 1 drop of phenolphthalein in a cell of the spot plate. So here I go. Got some phenolphthalein. I'm putting 1 drop of phenolphthalein in there, and nothing is happening. That makes sense. There's not an acid. There's not a base in there. Nothing is occurring. Number 6, it says is distilled water basic or alkaline? So I'm going to grab a bottle of distilled water. This blue tip you can see coming in, that's our distilled water. If it's got more hydroxide ions in it than hydrogen ions, that means it's a basic solution. And if it's a basic solution, this should turn pink. So I'm going to put some drops of water in there, and it is not turning pink. So that means one of 2 things. It means that water is not basic. That's what it means for sure. It could mean that distilled water is acidic. It is not. Distilled water has a perfect pH of 7. It's neither acidic nor is it basic. So we just answered 6 and 7. It then says you're given 2 bottles labeled X and Y. So I'll just give you a quick glance at those again. There's our bottles X, Y, and Z. They could be bases, they could be acids, and they are of different molarities. So we're going to be playing with those and the phenolphthalein to try to figure out what is X, what is Y, what is Z. Are they acids or bases? And then the rough molarities of those acids and bases. So I'm going to go back to our lab. We got things set up. All right, so here we go. We are going to be doing number 9, figure out which acid is a bottle and which is a base. So I'm going to take 1 drop of phenolphthalein and I'm going to put it in a clean, dry cell. Nothing happens. I put X in that cell. I put 1 drop of X in it and it turns pink. So we can see that pink color that is there. X therefore must be a base. We don't know anything about its molarity right now, but we do know it's a base. And then I'm going to put another eyedrop or 1 drop of phenolphthalein in that cell. I'm going to grab some Y. I'm going to put some Y in there. And when I put my 1 drop of Y in there, nothing happens. So Y must be an acid. So now it wants us to figure out the rough molarities of these. So number 10, X is a base, and what is its molarity? Y is an acid, what is its molarity? So right now, I'm going to put some Y into this pink solution. Y is an acid. Hydrogen ions are going to link up with hydroxide ions and turn it to water. So by adding an acid, that's what I'm going to do right now. By adding an acid, I am basically removing hydroxide ions. So I put 1 drop of acid in there, and I shake it. And that mixes up the hydrogen ions and hydroxide ions, and it remains pink. I'm going to put 2 drops of Y. So this is the second drop of Y. And you can see some of the pink went away in the center. I'm going to shake it, and it still is remaining pink. But some of that pinkness, as I shake it, is starting to disappear. But it still has some pink to it. I'm going to add a third. Oh, looks actually maybe like the pink is disappearing completely. Oh, a little bit's left. So I'm going to put a 3rd drop of Y in there. And with the 3rd drop of Y, all the pink disappears, which means I have made an acidic solution. So it took 2 or 3 drops of Y to neutralize, to wipe out the 1 drop of X, which was a base. So that means X is 2 times as concentrated as Y, or Y is twice as dilute as X. So if I go to bottle 10, or you go to line 10 or question 10, it says bottle X is a base, and it has a molarity of 1. And 11, Y is an acid and has a molarity of 0.5. It took twice as much of Y as it did X to neutralize it. Okay. I can do this another way. I'm going to add some X to this cell right here. This is where Y is with phenolphthalein. And with 1 drop of X, it should turn pink. So I'm going to put 1 drop in here. Because X is more concentrated, it should immediately turn it pink and keep it pink. And if I add that drop in there, you can see that pink. I'm going to mix it up a little bit. And that pink's a little bit lighter color, but it is remaining pink in color. So that means X is more concentrated than Y. This all comes into play later on this week. We're going to give you 6 bottles with, we're not going to tell you which ones are acids, which ones are bases, and we're not going to tell you the molarities in them. And you're going to do some playing around with experimenting to figure out what is each substance. So now it says number 12, it says now figure out what Z is. So I'm going to put some phenolphthalein into a cell. I'm going to add some Z to it. Add 1 drop of Z, and it stays colorless, so therefore Z must be an acid. Now it wants us to figure out the molarity of Z. Well, I know X is 1 molar, and it's a base. So if I add my 1 drop of base to it, I see some pink that formed. I'm going to shake it up. And the pink disappears. I'm going to add a 2nd drop of my 1 molar base. and it stayed a little bit more pink. I'm going to mix it up, and it all disappears. I'm going to add a third drop of base to it. It turned pink again. And this time it does not disappear. So it took 3 drops of base for 1 drop of acid. That means Z is 2 or 3 times more concentrated than X. So you could say Z is 2 molar. You could say Z is and up to 3 molar. So you could say Z is 2 molar all the way up to 3 molar, and you would be somewhat correct. That would be the ballpark range of it. So this pink solution right here, if I had 1 drop of Z, since it's more concentrated, it should all turn colorless. And in fact, it is turning colorless. You give it a little shake, and it completely turns colorless. Shake this pink one. Let's add a drop of Z to it, and it all turns colorless, meaning Z must be very concentrated. That's the idea of this lab, folks. If you have phenolphthalein and a base, it's pink, and if you add acid to that pink solution, it goes colorless. That's the key to everything that we are doing. Have a good day.